Hi, my name is Pranut Jain. I'm an assistant teaching professor in the School of Computing and Augmented Intelligence at Arizona State University. Today, I will present our work, Co-Designing Explanations for a Proactive Auto-Response Messaging Agent. This work was done at the University of Pittsburgh with my co-authors, Dr. Adam Lee and Dr. Rosta Farzan. Before talking about this agent, I will start by discussing the problem we are trying to tackle through this agent. In face-to-face conversations, people can visually observe each other's environments. Even for phone calls, we can listen to background noise to make inferences about other people's state. With mobile messaging, these cues are missing. To compensate, messaging applications use awareness tools such as online-offline status, last seen time, and read receipts. Although prior work has reported that these tools are actually poor indicators of availability. In messaging, there is also an expectation of fast responses. Prior work has reported that to meet these expectations, message recipients frequently check their phones to attend to incoming messaging notifications, which can cause distractions in their ongoing tasks. Prior work has also reported that delays in responding can also affect social relationships due to lack of situational awareness in messaging. To tackle these issues, we designed a messaging agent that sends auto responses to inform unavailability. Along with signaling unavailability, the agent also shares some context related to that unavailability. For instance, in this sample in auto response, the agent shares the user's calendar and proximity sensor information. Further, the agent is fully automated since it predicts users' attentiveness to messaging and acts on their behalf if they are unavailable. It also enables mutual awareness where the message recipient is aware that their context has been shared with someone since the response is part of the original conversation thread. The design and evaluation of this agent has been covered in our prior works, which are listed on this slide. I encourage viewers to review them for more details about this agent. Our focus in this work was to explore how we can design explanations and controls to make this virtual assistant more intelligible for its users. So what makes this agent unique? First, the agent acts proactively. That is, it predicts the unavailability of its users and takes some action based on this prediction without requiring user input. It also acts as an intermediary in human communication, which can have implications. Finally, the agent users are the experts of their behaviors, which the agent is trying to approximate. This is different than many contexts where we work with agents. In those contexts, the agents are the experts that guide us, for example, in a recommender system, whereas here, the agent is an assistant trying to understand what is the best course of action based on our prior messaging behavior. To make the function of this agent more transparent for its users, we need to understand how users reason about the design and action of this agent. We need to understand what are the users' motivations for designing explanations of this agent's behavior. And finally, in what ways can interactions with this agent create opportunities to learn from and teach the agent? To this end, we used a co-design methodology involving users of this agent to discuss their experience and articulate design solutions to their perceived limitations of this agent. The study design consisted of three main parts: briefing to explain the purpose of the study, familiarization, where participants used the agent for 2 weeks to familiarize themselves with its function, and finally, the design session, which was conducted remotely with participants paired randomly into dyads. This slide shows one dyad's output at the end of their design session. Next, we discuss our findings. We coded the recorded design sessions, and the following were the main themes that emerged in our analysis of the transcripts. First, participants' discussions started with speculation, where they collected evidence through observation and prior experience to guess the agent's function. Next, participants gained more confidence or rejected speculations as they observed more agent actions and interacted with their partners during the session. Third, there were also instances where participants desired explanations to update their understanding of unexpected agent outcomes. And finally, most participant discussions cumulated to them wanting to influence change in some aspect of the agent's behavior to conform to their expectations. Another important aspect of our finding was how participants transition between these concepts, which I will discuss next. Participant speculations transition to learning when they confirmed or rejected speculations, as I mentioned before. For instance, participant E1 mentioned that they confirmed their speculation by asking their partner to send them a message to verify whether the location was a factor in agent's actions or not. There were also cases where some observations caused participants to desire an explanation. For instance, E2 mentioned that they observed that noise level caused the agent to send an auto response, but when they were in a noisy environment and expected the agent to respond as such, which it didn't, resulting them wanting a clarification. Participants also transitioned from speculating about agent behavior to wanting controls to change it, although often the desire for these controls was misguided. For instance, B1 incorrectly guessed that the agent had a fixed frequency with which it responded and desired the control to change this frequency, which is not possible since the agent decided to respond based on the prediction of the user's attention to messaging. On the other hand, when the participants had collected more evidence regarding their speculation about the agent's behavior through either repeated measures or interaction with their partners, they proposed more apt controls or more appropriate controls to affect agent outcomes. For instance, G2, after learning that the agent was sending responses when they ignored messages while watching a video of their phone, wanted to create a rule for the agent to not respond when they were actively engaged in their device. Finally, on multiple occasions, dyads indicated that explanations are not enough, and the reason they desired explanations was to be able to change unexpected agent behavior. To this end, dyad A designed some actionable explanations during their design session. So what are some design implications from our findings? We learned from our findings that the agent designers need to consider more adaptable proactive designs, which can start at lower levels of proactivity, that is, starting at proactive suggestions, and move up as the agent gains more confidence in its predictions. Further, there is a need to leverage user expertise for this messaging agent. Our dyads design simple feedback mechanisms, such as thumbs up and thumbs down, to give feedback to the agent. And finally, co-design sessions involving dyads enabled participants to exchange knowledge. Some participants even justified the agent behavior to each other. This warrants further investigation to include guided community-based knowledge exchange for future agent designs. For more details about this research, please check out the full paper and additional resources on my webpage. Thank you so much.